Hey guys, welcome to tutorial. This week is our fourth tutorial, and we're almost at reading week. So this is probably the last class for a lot of you guys for today, which is great. You're almost there. Here's what we're going to be doing today. We're going to be doing more practical coding exercises, which is pretty good because, as you guys could probably tell from your first test, most of the test content is actually applying like practical coding. That's kind of what Mr. Moore usually bases tests around. So it's a really good idea to know how to properly apply programming principles in actual exercises. So we're going to be doing more of that today. So we're going to be doing 3 coding bat problems, as you can see there, and we're also going to be taking up some of the problems from a practice test, which is the one uploaded on Avenue. And Mr. Moore might have mentioned that, he might have not. But yeah, that's what we're going to be doing. And then at the end, if we have any time, you guys can feel free to ask me any questions, and I'll happily help out if I can. All right, so let's start. We have coding bat first. So the first question we're going to be doing is make chocolate from Logic 2. Now, if you guys remember, I actually suggested, I think I suggested this problem at the end of tutorial 2, it might have been, to take a look at, like on your own time. So some of you guys might have done that. A lot didn't, probably. So we're going to do it again and actually take it up. So here it is. It's actually a pretty cool problem, with a pretty intuitive solution if you think about it. So I'll read it out for a sec. Basically, we're given a goal, which is how many kilos of chocolate we're trying to make. And we also have some number of small bars, which are 1 kilo each, and some number of big bars, which are 5. And then basically, we have to figure out if we are able to make up that goal with the number of bars that we have. So based on the number of big bars and the number of small bars that we have, can we make up that goal exactly? And if we can, then we have to return the number of small bars that we can use. And if not, then we have to return -1. So hopefully you guys have a good idea of what the problem is actually asking. And here we can see some examples. You can see that the goal is actually the third parameter in this function, which means that, for example, in this one, we have to make up 9 kilos of chocolate. That's our goal. And we have 4 small bars and 1 big bar. So you guys know that 4 small bars are 1 kilo each, and big bars are 5, which means that we have 4 kilos plus 5 kilos is exactly 9. So since we can make up the goal exactly, we return the number of small bars used, which is 4. Here we need to make 10, but we only have 9 kilos worth, so we return -1 because it can't be done. Here we want to make 7 kilos, which is our goal. We have 4 small bars and 1 big bar. We can make this goal by using 1 big bar and 2 small bars to make 7 kilos total, which is why our output here is going to be 2, because we're going to be using 2 small bars. That's pretty much the problem. Does anybody have any ideas on how we could approach this? There's actually a wide variety of ways to think about it, and some can be pretty convoluted, some can be kind of confusing, but there are also a few that are really, really naturally, like you can get those conclusions pretty naturally. And it all relies on the wording. So I'm gonna break it down. We're actually looking for the number of small bars. So if we know that we're going to be trying to return the number of small bars, why don't we just find out how many small bars we would have to return? And then if we have enough small bars, then we can say how many we're going to specify. And if we don't have enough small bars, then we just return -1, because that's basically what the problem is going to boil down to. So with that being said, let's start. We can basically say, oh, and actually let me zoom in for you guys. We can say that if the goal is going to be greater to the number of big bars that we have, then we're going to have a certain remainder. So I'm going to say the idea here is to calculate the remainder, which is how many small bars we need to use after we've used any relevant big bars. And I'm gonna break the line right here, just like that, okay? And so what can we say? We can basically say if the goal is greater than the number of kilos that are big, which is the number of bigs times 5, right? If we have 2 big bars, that's 10 kilos worth of bars. Then we know our remainder, which is going to be the number of small bars that we need to provide, is going to be equal to this, right? We're just going to subtract all of our bigs from that goal, right? Try and think about that. This should make sense to you guys. If the number of kilos we want is bigger than what what all of our big bars can supply in total, then the number of small bars that we're going to need is just the difference between that goal and the number of kilos that our big bars will provide, right? So that makes sense. And then if it's not, which means that the goal is less than the number of kilos that our big bars can provide, then that means that we have more than enough big bars to do the job, and the number of small bars we're going to need is actually this is the part that some people might get tripped out about. But and maybe I can use an example to illustrate this. So I want you guys to try and figure out what would go here, right? What's going to be the remainder if the goal is less than big times 5? And the example that I'm going to do here is, let's say we have the function being called with like 3, let's think, 2, 7, right? The answer here is going to be 2. And notice that that's because we're trying to make up 7 kilos. We're going to use 1 big bar, and then the number of small bars we're going to use is 2 small bars, right? To add the 2 to the 5 here, which is going to be 7. But the way we calculate that can't be this way, because we don't want to subtract all of our bigs, right? We actually have to take the remainder after dividing this by 5, right? Because since we have more than enough big bars, it's going to come down to the small bars that are remaining. So we're going to have this. It's actually going to be 7 mod 5, which is 2. Because when you divide 7 by 5, the remainder is 2. And that's what this modulo operator does. So hopefully that makes sense. By the way, feel free to ask any questions if you guys are confused. And now it's pretty simple, right? We just have to check if we have enough small bars to pay off this remainder, to make this remainder. So we can say if smaller is greater or equal to remainder, then return that remainder. Else, we can return -1 because we know it can't be done. Right? And that's it. And if we run this and we zoom back out, there's a lot of test cases because they are really extensive here, including this really big one to see if your code is actually efficient. But we've passed them all because our program does what's required here. So this is great. I'm going to copy this over to our notebook. I'm just going to put it there. Yeah, and you know what? I'm going to fix the formatting after. Like after I'm done with the tutorial, before I upload it to Avenue, I'm going to fix it then. But for now, feel free to ask any questions if you guys have any about this function. And in the meantime, I'll move on. If I see any questions, I can always go back. But yeah, guys, please ask questions if you have any sort of confusion. So the next function after make chocolate is xyz there, and that's under string 2. So we'll hop over to string 2 and check out xyz there. All right, here we go. So in this function, we have to return true if the given string contains an appearance of xyz, which is going to be a substring here, where the xyz is directly preceded, where xyz is not directly preceded by a period, which is a substring of just one period. So basically, xxyz would be true, but x.xyz would return false because we have the xyz preceded by a period, right? So we can think about how we want to approach this question. Basically, we have to go through the string and check every single character. And you know that that's going to have, that means that we're going to have to check each character, which means if we have a string of length n, we're going to have to make almost n comparisons, right? Which is not too bad. Now here's the thing. I'm going to be checking the string with a for loop. So I'm going to have something like this, right? But here's the issue. The issue is that I'm going to be using an iterator I to check every single character in the string. But when I check every character, I actually want to be checking not just that character that I'm looking at, but also the two characters in front of it. Which means that instead of only ever referencing I down here, I might actually be referencing I plus 2, right? Because I want to go two characters over from where I is at all times. But that means that I have to be careful because when I is at the end of our string, we start having the risk of running into an out of bounds error. Sorry. So notice that if I is currently pointing at, for example, let's say like this second last character of the string, I plus 1 is going to be the z, but I plus 2 is going to be trying to reference something that's out of the string completely, which is going to give us an out of bounds error and our program is going to crash. So we have to be careful. Instead of actually going all the way through the range of the whole string's length, we actually have to modify it to shift it over by a little bit by subtracting 2. This way, instead of going to the last character, we're going to go 2 before that. So the last value of I here is actually going to be referencing this x. That way, I plus 1 is going to be the second last character, and I plus 2 is going to be the last character. And that way we don't run out of bounds of our string. So now we know where our iterator is going to be going with respect to this range here. And we can actually start taking a look at the contents of the string, which is going to be something like this. If the string, and we're going to take a slice here, a slice of a string, which you guys should have learned about in lecture. Feel free to let me know if you guys haven't, but I'm almost certain that you guys did. We're going to take a slice of the string from I to I plus 3, and we're going to check to see if that's equal to the substring xyz. And if it is, then we'll return true. And if after running through our whole for loop here, let me zoom in, if we make it through this whole for loop and we never return true because this condition is never true, then we should return false, right? So you guys might be looking at this program and think that's fairly obvious, but there's also something that's missing, which is this whole period. We're checking here to see if the string contains xyz at any point, which is great, but part of the question says that appearance of xyz has to not be directly preceded by a period. So you might say, for example, okay, that's an easy fix. We just have to say, as long as we have to add a condition to our if statement and say as long as string at I minus 1 is not equal to a period, and you'd say, yeah, like if we add this condition to the string, now we're correct. And that's very close, but like this would work in the sense that it would tell you to return true as soon as you found an occurrence that of xyz that does not have a period right before it. But the one condition you're missing is the one that I'm going to demonstrate right here. So consider the case where we are passing in this string. And here's what the string is going to be. It's going to be something like this. Now, here's the thing. This string has an xyz in it, which means we should return true. But first we have to check, does it have a period before it? It does not have a period before it, which is exactly this condition, which means we should return true, right? Since this is an xyz that does not have a period before it, we should return true. That's what we're asked to do. But the issue with our code right now is that our code would actually return false for this case. And that's because if you look at this for loop and consider the point in time where I is equal to 0, right? AKA we're looking at this substring, right? Because I is equal to 0, I plus 1 is up to here, I plus 2 is up to there. Then we're only looking at the substring, but then I minus 1, since I is 0, is negative 1. And just to refresh you guys if you forgot, but indexing a string or a list at negative 1 actually points back to the last element of the list or string, right? Which means that this would actually like this would be caught in our condition, which is not good, because then this would be false, right? This condition would not run because it would say, oh, wait a second, the string at I minus 1 is equal to dot when it's looking here, because here is I to I plus 2, and here is I minus 1, which is 0. So we actually need to modify this again. We need to add one little bit. And that's to say, if I is equal to 0, or I minus 1 is not equal to the period. And we actually need to enclose this in brackets, because and binds more tightly than or. And we want this or to be together like this. We want this to be evaluated first, right? And then we want to and that with this. Because basically, we're saying, yeah, we want to check to make sure that the string contains xyz, and that the character right before that string is not a period. But if I is equal to 0, then we don't have to worry about the directly preceding character being a period, which is the idea of this, right? And there we go, right? That's pretty much the program there. And I'll say here, consider the following case. And this is why we need to add the and then I'll say, I guess, I equals 0 condition. And we'll copy that, and that works. So we'll paste it there. All right, once again, I'm going to format it before I upload. But if anybody has any questions about this function, feel free to ask. If not, then we'll just move on. And the next problem that we're going to do is sum 13 from list 2. So let's go over there. Cool. So sum 13, we want to return the sum of the numbers in the array. Let me zoom in. returning 0 for an empty array, except the number 13 is very unlucky, so it does not count, and numbers that come immediately after a 13 also do not count. Okay, that's not bad. That's not bad at all. So here's what I'm thinking. We can use a loop to iterate, right, over this list and add up the numbers. So we can store here a variable, we can call it result. We can initialize it to 0, right? And this is going to hold our sum, right? And here's the thing. We could iterate over this with a for loop, but what I think is going to be a lot easier is to iterate over it with a while loop. And the reason being is this whole 13 thing. When it asks you to not count numbers that come immediately after 13, I think the easiest way to do that is to have a while loop and then use our counter, which here is going to be I, right? To skip over the one directly after the 13. So what we can say is basically, we'll start looking at the first element, right, which is going to be nums at 0, or sorry, nums at I, which I is going to start off at 0, right? And we're going to see if that's equal to 13, then we're actually going to skip over 2, right? Because we're going to skip over an extra one than we normally would, right? Because in a while loop, usually you increment your looping variable by 1 each time. And if you increment it by 1 each time, then you're going to successfully go from one element to the next, to the next, to the next. But if on one of the iterations of a while loop we skip over by 2, then we're skipping over one element to the next. So if I, let's say for example I is right here, if this was to be 13 and we added 2 to I, then we'd go 1, 2, and we'd skip over 13 and we'd skip the one right after it without even looking at it. Right, so that makes sense. If that number is equal to 13, then increment I by 2. If it's not, then we want to count that number. So we're going to add it to the result, right? And then instead of skipping by 2 to jump over the number, we're only going to increment by 1. And that way, instead of hopping over a number, we'll just move on to the one that's directly after the one that we're currently looking at. And that makes a lot of sense to me. And I think here we can just return our result that we've been running. Let me run this, just check to see if it's right. Okay, it is correct. So I'll just quickly add some comments. I'll say increment our looping variable by 2 in order to skip an element in the list. Also, notice that we don't add the current element to the list in this case, right? So when the number is equal to 13, we're not adding that number to our sum, nor are we adding the next one, right? We're just skipping over, not by 1 to go to the next one, but by 2 to skip the one in between and go directly to the one after that. And yeah, so that works out, and it makes perfect sense. So I'll copy this over again and put it right here. Yeah, does anybody have any questions about this function that we just did? Or any of the previous functions, for that matter? Okay, looks like people are good for the most part. So we can move on to the next part of today's plan, which is taking a look at some problems from practice test 1. So let's do that. The first one that, oh, here we go. How to remove an element from strings. Is this a question related to one of the functions? Like, are you asking that related to something, or is that just like a general Python question? Okay, not related. Yeah. So it's not that bad. You can actually like, let's say for example you have a list here, 1, 2, 3, and we printed A. Then we said delete A at 0, print A. You can see here that this is how we remove something from a sequence, which yeah, would be the same thing for a string, I believe. We can try that out. We can try s is equal to a string. We can say Basil, and we can say del s at 1, for example, and then print s. Okay, actually, strings don't support this del, so this only works for a string. Right. Okay. So there are other ways you can do it. If you want to remove one particular element, I know you can do something like this. If we actually keep Basil there. Sorry. Okay. Delete. So what I know you can do for sure is if you wanted to, you could just slice the string, right? And I know this might not be very efficient, but or like pretty, but it is very efficient. It's let's say you wanted to remove let's say for example comp sci 1md3 was our string. We could do something like this. We could say s is equal to s, and then we can use splices. So Python slices is going to allow us to slice whatever part. So we can, let's say we wanted to remove this s, right? So look at which element that is. We have 0, 1. Sorry, let me zoom in if you guys need it. 1, 2, 3, 4. So it's going to be 4. And we can add it with that same string starting from something else. So starting from 5. And notice how I'm not putting anything here. Like, I could put a number here, but I don't want to because I want it to go back to the very end. And if you leave this number out in a slice, then it goes to the end. So leaving out the first number in a slice on the left side of the column means that it'll go all the way to the beginning, and leaving out the number on the right side means that it'll go all the way to the end. So here, if we print s, here you can see the difference between the two strings, right? Notice how the s was removed here. Is that kind of what you were asking, Drew? There are a few other ways to do this as well. A few of them are kind of slipping my mind right now, but you could just Google how to remove an element from a string in Python. If you don't know the position of that element, so you know what the okay, yeah, so there is actually a way to do that, but like you would basically be having to refer to the actual character that you want to remove, right? Like you would have to say, I want to remove um, character M, for example. Is that what you're going with? Yeah, okay. So you could say something like this. You could say instead of this, you could say s dot replace M with nothing, right? And then you could print it. Sorry, we have to assign it. There we go. So this would remove all of the it would replace every M with a or do you want to just do one? Yeah. Okay. Cool. So yeah, feel free to Google it, by the way. There's definitely more ways to do it than what I just described. And that's one of the nice things about Python too, is that it's very it's very there are a lot of ways to do the same thing. Cool. Yeah, so let's get back to what we were doing, which is taking a look at the practice test. So the first question that we want to look at, or that Mr. Moore recommended that we look at, is this Roman numerals function. And we can read it. Basically, the function wants us to convert an integer to its Roman numeral representation and via a string, right? And it says try to use lists or dictionaries, and we have some examples of what this function would look like with its inputs and its outputs, right? So for example, if the function takes in the number 1 as an integer input, it should return a string I. 5 should return V, and here's some more examples using the Roman numerals that exist in the world. So we could take a start at that, and here we have Roman numerals from practice test 1, week 4 on Avenue. Cool. So let's try and do this. The way we're going to do it is actually by using a dictionary, as they suggested, and we're going to set up a dictionary just for that. So let's start by saying, I don't know, we can make some sort of number dictionary, and it's going to be dictionary, which means we're going to represent it with this these curly braces, right? And we're basically going to create a map of numbers, which are integers, to strings, which are the Roman numerals. And so we're going to have one for each denomination that we would need to use, right? So we'll have, for example, 1000, as you guys hopefully know, is M. 100 is C. And actually, in between, we have 500 is actually equal to D. So we're basically just creating a dictionary that's mapping numbers to strings, right? And we're going to create a mapping for every single number that we would have to use on its own in a Roman numeral string, which would include 900. And I'll explain this a little bit more later on, but it actually does include the 9s and the 4s, if that makes sense. So this would be CM, because it's basically 1,000 minus 100. So we have the M, but we have the C in front to signify 900. And similarly, 400 would be, as you guys can probably guess, CD. And we're going to want 90 as well. 90, I'm sure you guys can figure that one out too. It's going to be XC, right? 50 is L. 40 is 50 minus 10, which is XL. 10 is X. What else do we have? We want 9, which is IX. We want 5, which is phi. We want 4, which is IV. And that's it. And then we want 1, obviously, which is just I. And so what we can do with this dictionary now is we can use it to incrementally generate the string that we want to return. So we want to return a Roman numeral string from the integer that corresponds to the integer that we're given, right? So now that I have this number dictionary, we can actually write our algorithm, right? So let's create a string that we're going to store our result in. We can call that result again. And this is going to start off as an empty string, but what we're going to do is we're actually going to populate that empty string letter by letter as we build it up, right? And the way we're going to do it is we're going to modify our input string as we go along. So if we go back and take a look here, the function is going to be called Roman, and it's going to take some value n. So we're going to define a function called Roman that takes in an integer value n, right? And we can start cracking along at it. We obviously want to have this inside. And this is what we're going to do. We're going to say as long as n is greater than 0, we're going to keep doing something. And basically, n is obviously going to start off as a number. It's going to be our input. But every time we use one of these Roman numerals and add it to our string, we're going to subtract that Roman numeral representation, the integer representation, from n. And that way, we're going to keep on subtracting from n until we've basically used it all up and converted it all to Roman numeral strings, which is going to be in our result string. Cool. So basically, what we're going to do is we're going to check every single number in the number dictionary to see if we can fit it inside n, right? For example, let's say we wanted like 6, right? We would check, do we want to use m? No, m is 1,000, that's too big, right? So we would check every single one by one, until we got to the one that actually fits inside our number. And so 5 would be the first one that fits inside of our number. So yeah, something like that, right? We're going to say for I in number dictionary, we're going to take the one that fits. But we're not only going to take it once, right? We might need to take multiple of them. So for example, if you take into account the number 7, if we had 7, we want to use 1 5 and 2 1s, which means that we want to take as many as we can until we run out of room. So for I in number dictionary, we're going to say while n is greater or equal to I, right? While n is greater or equal to I, we're going to add to our result whatever that string is, so number dictionary at I, and then we're going to subtract from n whatever that integer value is. So we're going to subtract I from n, right? Because when we say for I in number dictionary, I here is iterating over each of the keys of the dictionary, which are these integers. So those are the keys, and the values are these strings that belong to each key, right? So they're key value pairs. That's how we call them. And so you can see here, for I number dictionary, while n is greater or equal to I, add that value of I onto the result string. So for example, in the case of 7, right, if our input n was 7, while n is greater than 0, yeah, n is 7, so 7 is greater than 0. For I in number dictionary, while n is greater or equal to I. So 1000, is that greater or equal to I? Yes, but it would not fit. And so something like that would not work. But here we're testing n. Sorry, that was a little slip up. N here is actually 7, right? So here I is going to be 1000. We're testing. Is 7 greater or equal to 1000? No. So we're basically going to check that for each one of I, right? For I in number dictionary, until we get to the first one that fits, which is this one. And then we're going to say while n is greater or equal to I, for each time that we can, add it to the result and subtract that value from n. So we're going to add a v to our result string, and then we're going to subtract 5 from our n. So n is going to go from 7 to 2, and our result string is going to have a v on it. And so now, this while loop is done. So we terminate from that, and then we continue going through here, right? Which means we're going to get to this one, and we're going to check, is this is n, which is currently 2, is that greater or equal to I? Yes, it is. So as long as it is, we're going to add it to the result string, and we're going to subtract that integer value from n. So this is going to happen twice then, right? Because it's going to be greater or equal to I twice. So first, we'll add an I to our string, and then our n is going to go down to 1. 2 minus 1 is equal to 1, right? And then it's going to happen again, because this while condition is still true after the first iteration. Because now n is equal to 1, and I is equal to 1, which means 1 is greater or equal to 1. So we add a second I to the result string, and our n goes down to 0. And now, once this loop terminates, this while condition will be false. So our whole outer loop will terminate at that point, because we're done. And so that's really it, right? And at the end of this whole loop, we can say something like return results, right? Because we obviously want to return the string that we just worked on creating that whole time. And that's it. So how about we write some test cases for ourselves to see how this string works out. Let's look at theirs, right? They use 1, 5, 9, 39. So we can use some of those as well. CMX, CIX. And if we check the practice test, that's the correct output, which is great. We can test it on other things, like we can just copy this a bunch of times. For example, 500, that's D, which is correct. Let's test 1, let's test 39, let's test 49, and then we can test like 216. And yeah, this is all right, which is great. So that's that. And feel free to ask any questions on that. We have 5 minutes left. And there was one more thing that we were supposed to do, which is this greatest common divisor. And lucky for us, it's really simple because the question on the test basically just says write a function, GCD, which takes in two numbers, and returns the greatest common divisor of those two numbers, right? And greatest common divisor algorithm is a very famous problem in computer science and mathematics. So lucky for us, there's a million different algorithms, including one of the most famous ones, which is the Euclidean algorithm. So if you just even Google Euclidean algorithm or GCD algorithm, you get this algorithm which is very easy to implement. In fact, if you scroll down a little bit, you see that there are actually plenty of implementations to write this function. And obviously they're not written in Python, they're written in pseudocode, but you can abstract this away and basically get the correct answer, right? So here's a very simple recursive solution, which means that we call the same function that we're actually defining from within that function. Yeah, I'm not sure if Mr. Moore has mentioned recursion to you guys yet, or taught that topic. So maybe that's not the best implementation to use. But there's also other implementations, such as this one. And we can easily just copy that over. And insert that. Right, we could have the same ones that they wanted, which are n and m. And while m is not equal to 0, we have some temporary variable, which is, here we can call it t. We can actually, let's just call it temp. And the modulus in Python is the percent sign. Right, and these assignments are equals in Python. So you can just make the adjustments necessary. Something like that. And we return n. And if we try calling this function on, for example, 36 and 27, and we fix our syntax error, we get 9, which is correct, right? Let's actually print that instead of putting it to the output. Just like that, we get 9. Right, we can copy this over, do 125, we get 25 there. We can do 270 and 30, we get 30. We can do 999 and 22, which is 1 because they have no common divisors other than 1. And yeah, that's pretty much a very simple function for calculating the greatest common divisor. And yeah, that actually makes up the whole tutorial. So that's everything we needed to cover. If anybody has any questions about any of the functions that we've written, or obviously about anything else, I'm going to be here for a couple minutes, so feel free to ask away. But if not, then have a great reading week, guys. And yeah, enjoy it, and I'll see you guys for the next tutorial. Yeah, I'll be here for any questions if you guys need it. Yeah, no problem. No problem. Have a great reading week. Okay, I don't see any questions, so I'm going to end the stream. Feel free to message me on Teams if you guys have any questions, and yeah, I'll see you guys next tutorial. Bye.